Hi, welcome back to Always Eclectic Stacy and our 5-minute chemistry series. This is the covalent bond series where you're learning how to take a covalent formula and convert it to the covalent name. This is our 9th example. Now, please go ahead and grab a pen, paper, pencil, periodic table, and I'll see you on the other side of the intro. Let's go. Hi, and welcome back to Always Eclectic Stacy. We're in our covalent bonding series, and we're taking covalent formulas and converting them into covalent names. Now, if this is the first video you have or you're a little shaky, go ahead and pause this video and watch the videos on your common non-metallic roots and your common Greek prefixes, and that might give you an idea of some of the more delicate naming techniques we're going to be using. Otherwise, you can jump right in. You're definitely going to need a periodic table or a good brain for memory. And if you've watched this series before, this is the time where you pause and see if you can get the same answer I'm getting. We're going to use the sentence diagramming technique so that you can see how everything gets pulled apart and put together. And I always color code so you can see where everything ends up in the final product. Ready? Let's go. The first thing we're going to do is look at the subscripts and assign a Greek prefix to each element so that we can make sure that we are properly representing how many of the elements there are. So O₂, the 2 is attached to that O, and the Greek prefix for 2 is di. So we're going to do that for O₂, and we're also going to do that for F₂ because it's the same subscript. So that makes it easy. Then we're going to look at our periodic table and we're going to name each element in accordance to the periodic table. So we're going to look up the element symbol O, and that's going to give us the element name of oxygen. Then we're going to look up our element symbol F, and that's going to give us our element name of fluoride. And if you ever have trouble writing fluoride, remember it's F-L-U-O-R because O-U-R is flour, and we're not taking a flower for a ride, for fluoride. Sorry, another brain tickler that sticks in my brain. Now remember, for the second element, I already did it here. So this should have been fluorine, but I so rarely write that I just wrote down the next part. Please excuse me. And we're going to go ahead and take out that Greek root, the common non-metallic root of fluor, F-L-U-O-R. And we're going to add the suffix "ide" to show it's our ending unit. So I wrote it first. My brain often skips this part only for fluoride because it's so common that we very rarely write the word fluorine unless we're talking about the element by itself, but almost always in chemical compounds is fluoride. So I am so sorry for my brain jumping the gun there. And then what we're going to go ahead and do is put this all together into a full name, and that's going to be dioxygen, difluoride. Again, thank you so much for watching Always Eclectic Stacy. If you like this content, please don't forget to like and subscribe and check out some of my other videos. I really appreciate it. Have a great day, everybody.